Today we're going to review scientific notation. So we had a homework assignment on scientific notation. We were practicing going to and from scientific notation, and we had some calculations at the bottom. Today we're going to go over the answers to those calculations and make sure that you don't have any questions on how to do these problems. So if we take a look at the first section here, it says, please express the following numbers in scientific notation or in standard form as appropriate. Now, we're starting off with numbers in standard form, so obviously we're going to be taking these to scientific notation. So, as a reminder, when a number is in scientific notation, one non-zero digit, so a digit between 1 and 9, should be to the left of the decimal point. So in this case, our decimal point is going to end up right here between the 2 and the 3. So we're going to have an answer that is equal to 2.301 times 10. Now, to get it, the decimal point to this position, we have to move it 1, 2, 3, 4, 5, 6, 7 spots to the right. So we're going to put a 7 up here, and because we have a decimal, that's going to end up being a -7 value. The other important part is this number has 4 significant figures. It's important that our final answer also maintains those 4 significant figures. So this would be 1, 2, 3, 4. Same thing here. 1, 2, 3, 4. Problem number 2. Right now, even though there's no decimal point located there, there is a decimal point down here behind the last 0. When this is in correct scientific notation, the decimal point needs to end up here between the 1 and the 9. So in this case, we're going to get a final answer of 1.9 times 10. We're going to move the decimal place 1, 2, 3, 4 spots. So we're going to have a 4 here. The reason the value is positive this time is because we have a large number, a number that's greater than 1. So with numbers that are greater than 1, their exponents will be positive. Numbers that are less than 1 or decimals, their exponents are going to be negative. The other thing that I want to point out is this. This is the number 19,000. It has just 2 significant figures. So our answer can have just 2 significant figures. This is not a case where we would keep these trailing zeros because we want to limit ourselves to just 2 significant figures. We look at problem number 3. The decimal point should end up again with just 1 digit to the left between the 9 and the 6. So this answer will be 9.605 times 10. To move the decimal point, we need to go 1, 2, 3, 4, 5, 6, 7, 8 places. This is a number greater than 1, so it's a positive exponent. And we have 1, 2, 3, 4 significant figures. 1, 2, 3, 4 significant figures in both spots. Problem number 4, we have 2.48. Now, this is a unique challenge, right? Because the decimal point is already in the correct spot. So we're going to put it into scientific notation without moving the decimal point. So we have 2.48 times 10. I move the decimal place 0 spots. So this is times 10 to the 0. I have 3 significant figures here. I maintain 3 significant figures here. In problem number 5, the decimal point is going to end up right here between the 2 and the 3. Again, only 1 non-zero digit should be to the left of it. So I have 2.300 times 10. And I'm going to move the decimal point 1, 2, 3, 4, 5 spaces. I have a decimal, a number smaller than 1, so it's going to get a negative sign. And notice how I had 1, 2, 3, 4 significant figures, and I keep those 4 significant figures. That part is very important. Okay, let's take a look at our last example on this slide. We have 902. So that decimal point is going to end up right here in between the 9 and the 0. Now, to get there, I move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spots. This is a really large number, much greater than 1, so we're going to keep that as a positive exponent. This has 1, 2, 3 significant figures, and our answer has 1, 2, 3 significant figures. Now we're going to take a look at some problems where we go from scientific notation back to decimal notation. So here we have some numbers that are in scientific notation. We're going to convert them into decimal notation. So in this first one, first thing that I want you to look at is we have a positive exponent. So this is going to be a number that's greater than 1. We're going to move that decimal place from where it is 23 spaces. So 1, 2, now I have 21 more spaces to move it. So I have 602, and now I have to add 21 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Notice that I don't put a decimal point at the end because that would convert all of these into significant figures, and we don't want that. We want to maintain the 3 significant figures that we have right here. Now, this is not some kind of joke. This is actually a number that we use in chemistry all the time. It's called Avogadro's number. And it is basically like a special name that's given to a number that scientists use when we count out atoms, molecules, and different particles. Because particles are so small, we need a large number in order to count them out. It's just like when they serve you donuts at Dunkin' Donuts, they serve it as a dozen, and we know that a dozen means 12. Well, a mole of something means 6.02 times 10 to the 23rd of that thing. Let's take a look at our second example here. We have 6.900. This time we have a negative exponent. So in this case, we're going to start there, but we're going to move the decimal point to the left because we need to end up with a decimal number. So we're going to move it 1 space and then 5 additional zeros. 1, 2, 3, 4, 5. Put my decimal place there. I'm just going to put that 0 out front so we don't lose the decimal. So this is the number 6.900 times 10 to the negative 6 written in decimal form. The nice part about scientific notation is that you can go back and forth. So if you want to check your answer, just put it back into scientific notation and make sure you get this number. So if I were to put this in scientific notation, I would have to end up with a decimal here. That would be a move of 1, 2, 3, 4, 5, 6. 6. I have a decimal, so it's a negative value for the exponent. Let's take a look at question number 9. We have 4.0001. Now, I have moved the decimal place 1, 2, 3, 4 times. I need to move it 8 times, so I have to add on 1, 2, 3, 4 zeros here. Just a reminder, I forgot to mention this in the previous problem. We have 4 significant figures here. We maintain 4 significant figures here. In this example, we have 1, 2, 3, 4, 5 significant figures. Here we have 1, 2, 3, 4, 5 significant figures. Sometimes you will encounter an example, and I'm saying this because this is what's going to happen in example 10, where you are unable to maintain significant figures when you go from scientific notation to decimal notation. If this were to happen on a test or a quiz, this might be a problem where you are forced to report your answer in scientific notation in order to maintain the correct number of significant figures. Let's take a look at this example. We have 8.10. We have a positive exponent, so we're going to wind up with a big number. So we get the number 810. So I've moved it 2 times. Now I need to move it another 3 times to get to 5. So I have the number 810,000. In this example, there is no way to maintain 3 significant figures. We can't put a decimal point here because that would change the magnitude of the number. We can't put a decimal point here because that would give me 6 significant figures. So sometimes you are unable to maintain the correct number of significant figures when you're going from scientific notation to decimal notation. And and that's okay. But be aware that if it happens on a test or a quiz, you might be forced to report your answer in scientific notation if you're able to, in order to maintain that correct number of significant figures for the calculation. What we're going to do now is we're going to take a look at some calculations with significant figures. So when we are calculating with significant figures, it's almost more important for me to know that you are reporting your answers correctly than reporting the correct number. I understand that sometimes things happen when we type numbers into our calculator, we might end up with the wrong answer. But as long as your work is there and you're showing me your method, you're going to be in good shape. So let's look at this first problem up here, number 11. Notice we have one significant figure here, one significant figure here. So our answer can only have one significant figure. So if you type these into the calculator, this is the answer that you will get. For the second problem, keep in mind that this is addition and subtraction. So this is really the number 1200, and we're adding it to the number 230. So that's why we're able to keep both the 4 and the 3 on this problem, because we are using numbers that don't have decimals, essentially, these two right here. In problem number 13, when we multiply this out, we start by, or our calculator gives us this answer. However, because we have two significant figures here and two significant figures here, we actually have to report our answer as 2.0 times 10 to the negative 1 in order to get back the two significant figures that we need. So just be mindful of that. Sometimes the calculator is not aware that you are trying to maintain significant figures. It might report the answer like this, but you know that you would have to report the answer like this because of our rules for significant figures. Here's the answer to question number 14. Again, same setup here. This is really the number 7,800. We're subtracting the number 240. So we can keep all of our digits because we don't have any traditional decimal places. And then finally, with our last example, we have two significant figures here and 3 here. This is the answer that our calculator gives us. We're limited to just 2 significant figures because of the number 7.8. So I have to report this answer to 2 significant figures. So remember to look here, go behind it, it's a 7, that makes it an 8, and we wind up with an answer of 2.8 times 10 to the negative 4th. All right, that wraps it up for the scientific notation homework. Please let me know if you have any questions and send me a message through either Schoology or through email. Thanks a lot, everyone.